So screen is visible.
Yes, sir.
Okay. So in previous class, we were discussing first chapter of the data mining book. Good. So we discussed several definitions and concepts, and we discussed association analysis somewhat, few details. Then classification and clustering, and this neural network. So this clustering we were discussing, and based on similarity between the items close to each other in one group and the items which are dissimilar from the items in another group. Okay, so we make this kind of grouping, and this is called cluster. Then outlier analysis we also discussed. We were here. In the process of data mining, we generate or we have, as a result of mining, very large number of patterns. Okay, thousands or sometimes millions of patterns we have. Now, question whether all patterns are useful or interesting. Okay, so if interesting, then how to say it is interesting or not interesting, or how to measure the interestingness of a pattern. Okay, so we discussed when pattern is interesting if it is easily understandable by the humans, valid on new or test data with some degree of certainty, and potentially useful. And if it is novel, then still it is supposed to be interesting. Okay. So how to measure the interestingness? Here we were. So two kind of measurement can be objective measures and subjective measures. You might be aware with the types of question. In many examination, you have objective type question. Those questions have only one specific answer or more than one. So you just select the choice and that's over. So if all students solve that question, the answer will be definite. So objective measure means just like objective question where answer is well known and there is unique answer, right? Subjective question, just like questions we have in conventional examination, explain, define, describe. So you write your answer in form of text or language, sentences, etc. So when a student writes answer, so his answer may differ with the answer of other student. So all the students have answers, but if you see the text or answer sheet of all students, and rarely it is the case that two students use the same text or same sentence. However, the meaning may be somewhat same, but language used by the student may differ. So this is called subjectivity. Okay. So such questions are called subjective questions. Similarly, here we have two kind of measurement. One measurement, well-defined rule, formula, okay, some numerical uh, measurement. So those measures are called objective measures. And here subjectivity of human being is involved. Okay. So, for example, suppose human beings, if you ask somebody how good this uh, cloth, how good this house, so everybody used to say it is good, it is bad. But what is the meaning of goodness or badness, and what is the meaning of other person goodness or badness? Both can vary. So this kind of variance or variability you will find in the opinion or answer. Okay, so those kind of measures are called subjective measures. So here you see support and confidence. They are the objective measures of interestingness or association rules, and we use this kind of form. And we define these measures using well-defined formula. Okay. Other measure is the accuracy coverage. So they are also objective measures of interestingness for classification if then kind rules. So mathematically, support and confidence are the probabilities. Okay. If we try to represent support, then we have this definition. For support x to y, it is defined as the probability x union y. Meaning is that when the items x and y both are occurring in transactions together. Okay. So the probability when both x and y are occurring together. So it is represented by this formula. And similarly, confidence, it is defined as conditional probability. So for x to y, probability by x, meaning is that the probability of occurring y when x is already occurred. Meaning is in a transaction, we search or we try to observe or we find or compute the probability of occurring by in a transaction if X is already present or occurred in that transaction. Okay, such kind of condition, such kind of probability is called conditional probability, and in school classes it is taught in chapter of probability. So conditional probability of occurring by when X is already occurred, right? So in general, each interestingness measure can be associated with a threshold and may be controlled by the user or may be controlled from outside. Meaning is that these measures, if I say that the minimum support should be so and minimum confidence should be so and so, that means I am restricting. Okay. So these kind of measures can be controlled by putting so and so restriction by the user. Okay. The other kind of measures just we discussed objective measures, interestingness measures for classification, if then rule, accuracy. How this accuracy is defined? It is a percentage of data that are correctly classified by a rule. Okay. So when we take unknown data, it predicts. And based on the prediction of class, so what we used to do, we test our several data and check whether the prediction is correct or not. Based on that, we measure in form of percentage. Okay, so it is a percentage of data that are correctly classified by a rule. Then coverage. It is also a percentage of data on which rule is applied. Meaning is that when I take test data, okay, Suppose I have 1000 number of data, and out of 1000, I test only for 700. Okay. So I will say coverage is 70%. So this value 700, 1000 is 70%. So it is a percentage of data on which rule is applied. So I am applying on 70%. So my coverage of data is 70%. And it is like a support. Okay. Objective measures help in identifying interesting patterns. However, they are not sufficient in describing needs and interests of a particular user. Now, in reality, objective measurement are not complete. Okay, so we have to take help of subjective measurement. So what happens here? Objective rules need to be complemented by subjective rules. So first of all, we compute interestingness or other some parameter with the help of objective measures. Then we take opinion or help of some expert. So based on their opinion, we say, okay, now it is interesting or it is somewhat useful or not like. There may be many patterns appearing interesting based on objective measures. However, such patterns supposed to be uninteresting if they represent common sense. Here meaning is that suppose we do mining and after mining we have rule like that if you work hard you will get more marks. Now everybody understand this kind of reasoning. So this kind of knowledge and by mining if you are getting, there is no sense of this kind of exercise of mining. So when we do mining, then we have several such kind of patterns. Those could be understandable or understood by simply common sense. So those patterns we generally say they are not useful. Subjective Subjective interestingness measures are based on user belief in the data. So if we study subjective measures, so there is a problem with subjective measures. They are biased with user belief. Okay, or the person who is trying to interpret or trying to apply subjective measures. So there may be possibility. We cannot say with complete accuracy this statement is correct, but there is always chances some kind of the biasing based on the belief of the user or expert that have the opinion. So there may be such kind of sensitiveness or issue in subjective evaluation or subjective measures. These measures find pattern interesting if patterns are unexpected. Okay. So unexpected means some contradiction of the user's belief. Sometimes we get the pattern and this pattern gives some opinion which is contradiction of the conventional or current opinion of the user. Immediately this pattern will be interesting and we need to pay attention why it is taking place and why the result is like so and so. Okay. Or offer strategic information on which one can act, or it suggests some kind of new information that could be helpful to make the strategy. Okay. So strategic information. So the patterns offering strategic information are called actionable patterns. Actionable means the pattern information is so useful we can act on that. We can take action on that. So such patterns on which the action we used to take or action is recommended or suggested, we call actionable pattern. Now, one question here. Can a data mining system generate all the interesting patterns? Hmm. So, what is the answer here? All the patterns interesting. How to decide whether the generated patterns are all as it was expected by the user or as it was supposed to be. So basically, it refers to completeness problem. Okay, whether a data mining algorithm is complete. So complete means it is generating all the results. So it is unrealistic to think and inefficient to generate all the patterns for data mining system. On one side, we told that if we try to generate patterns, then data mining system can generate millions, thousands, large number of patterns. So we say all those patterns are not interesting. So we should try to avoid such kind of unnecessary generation of the patterns, so and so. Okay. Second side, we are saying no. The algorithm should be such that it should generate all the patterns, right? So here the statement, if I make that, the algorithm should generate only the interesting pattern, only the interesting pattern, and somewhat okay. This such kind of algorithm we require. Okay, so it is unrealistic to think and inefficient to generate all the patterns for the data mining system. So here, however, in case of association rule mining, the use of constraints and interestingness can ensure completeness issue. For example, we used in association rule threshold value. Okay, so if we do that kind of exercise, then certainly we can be confident that my algorithm is complete and it is generating all the pattern with so and so limit. Okay. So once interestingness is defined such that so and so patterns are being generated, then I can say my algorithm is complete in that sense. Other question we see here, can data mining system generate only interesting patterns? This is the desirable that a data mining system should generate only interesting pattern. Can whether it is possible or not, what is required, it is highly desirable for a data mining system or systems to generate only interesting pattern. Actually, it is the desirable, it is the requirement. This is what we supposed from our data mining system or algorithm. But uh, whether it is possible, available or not, okay. So I will show you next page. So here it is written, progress has been made in this direction. In this direction means the expectation or the requirement that the system should generate only the interesting pattern. Okay, some work, some research has been done, and some uh, more is required. So even then, such optimization problem is a challenging data mining problem. This is an open problem, and one can go ahead. for further research in this direction. Now we come to the machine learning. Nowadays we have a lot of discussion on machine learning, and we have a lot of talk. So machine learning, just like the way humans try to learn, we want that machine should also learn like humans. Okay, so we try to develop the algorithm such that they have the ability to learn like humans. Okay, so in machine learning and this in data mining, you will find a lot of similarity. Okay, there are many similarities between machine data mining and machine learning. So, like machine learning is means learning process or algorithm as human learn, or we try to simulate the learning practice made by humans using machine. So, one very simple example: when somebody commit a mistake, okay, and even next time, generally many people they committed some mistake, they learn from their mistake, and next time they try to avoid that mistake, or they never used to do that mistake. Okay, and if somebody continue to commit the same mistake, so generally people used to say he is a foolish person, he is fool. Okay, बेवकूफ जैसा बोल देते हैं. So simply here is that simple many peoples have tendency if they commit a mistake, they try to avoid that, and they don't repeat in future, and even they learn from that mistake. Okay, so some what they used to say, uh, don't repeat the mistake, learn from the mistake and go ahead. Okay, so machine learning, we can have machine learning process or in three category, or even sometimes it can be four types of learning. One is supervised learning. Okay, second is unsupervised learning, third is semi supervised, and fourth is active learning. So we see here what is the supervised. Supervised learning means some supervisor is there, just like you are learning here in this teaching, and my presence is there. I am somewhat supervising, guiding, or helping you. So learning in the presence of supervisor or with the help of supervisor. Okay. Here supervisor means not only humans, the knowledge of the person is useful here. So here teacher means the knowledge of the teacher. In our data mining, classification is one example of supervised learning. Here learning comes from labeled examples of training data set. The knowledge of classes or labels of training data, okay, it helps in making or developing the classification model. So the knowledge of the labels is used here. So that's why it is called classification. So class labels name act as supervisor here. Second is the unsupervised learning. This learning is the, so in data mining we have example of clustering. So this is unsupervised. Unsupervised means when teacher is not present, even then a student learns from his own efforts at his own level. Okay, so when in the absence of any existing or available knowledge, we call such kind of learning process as clustering. And in real life, learning by doing. Okay, this is one simple example. Or there is no help is available. Okay, no person is present to help you. So not only person in physical sense, other source of knowledge are not conventional source of knowledge, they are not present. Even then you do something and you learn from that. Okay. In data mining, we say the data labels are not present. The names of data are not present. So no prior knowledge for supervision is available. No knowledge about the labels for data is available. We use clustering to discover classes. Okay. Third kind of category can be semi-supervised. That means combination of both labeled and unlabeled data are used to train learning model. So this kind of learning is semi-supervised. One more learning that is called active learning. Here humans, domain expert, play an active role to train a data. Meaning is that we have data do not have any label. We take help of user or any human expert that will suggest that this data should have so and so level. Okay. And based on the knowledge of that expert or user, in the beginning we have that so and so few data that can be used to train a model. Okay. So here human user or domain expert play an active role to train a learning model. So the user or domain expert is asked to label an unlabeled data. The goal is to optimize model quality by actively acquiring knowledge from human user with constraint on how many examples they can be asked to label. So when we take help, then what we used to do, we take few number of data, suppose 100 or 1000, and we ask the expert to label them or class names. Okay. Afterward, we use those data and train model, and then we develop the model. Okay. So what happens here? The use of expert in the beginning helps in speeding up the process of the high quality classification model development. Okay. So this is called active learning. So this was the first chapter of the Camber book. And in next class tomorrow, I will discuss few slides. Those slides have very good picture and some other simple explanation. And those slides are from the second edition of the 10 book. Okay. And after that, we take a new chapter. Any question you want to ask so far, you can ask. So I close the meeting. Okay, thank you.